Have you ever wanted to expand your Arduino project? Well, today we're going to see how to connect multiple microcontroller boards. We'll mention some of the reasons why you would do this. I'll show you the wiring diagram and the code. Why would you want to add multiple Arduino boards to your project? Well, I'll give you a few reasons, not an exhaustive list, but a couple. You may need more processing power for those projects that require significant computational power. You can distribute that task among multiple Arduinos, and that might make sense for you. You may need additional I/O pins for expanded capabilities. A single Arduino might not have enough input-output pins for a large project if you're connecting a lot of sensors and other peripherals, so connecting multiple boards could make more pins available. You may need additional boards for data logging and processing ability. For projects that are handling large amounts of data processing and analysis, multiple boards can handle different streams of data. That may be helpful for you. You may need to add additional boards for advanced robotics. In robotics, you may need dedicated boards for specific tasks, like handling sensors or managed communication. This would also be suitable for interactive art projects. For instance, you've probably seen Christmas display projects that involve complex user interaction or multiple display elements. Overall, this allows you to create more versatile, complex, and scalable projects than would be possible with just a single board. Here are the items I'll be using today. I'll be using the SparkFun Redboard Quick version, the SparkFun MP3 Player Shield, and 2 of the Arduino Mega boards. I'll be using a half-size breadboard, some male-to-male jumper wires, and some male-to-female jumper wires for the motion sensor. I'll be using the HC SR501 PIR motion sensor, and don't forget your micro SD card. I'm using 32 GB. I'm using 2 separate 5-volt power supplies, one 4-amp and one 2-amp. I'm connecting one to the 2 servos and then one directly to the LED lights, just so I don't have too much current going through a breadboard. I'll also be using 10 LEDs from a strand of WS2812B LEDs. I'll also be using 2 servo motors, the MG995. When providing power to your servo motors and your LED strip, you're going to want to consider the maximum current that you can safely run through a breadboard. I don't exceed 1 amp on the rails, on the power strips on the side. If exceeding the current limit on your breadboard is something you're concerned about, there are alternatives such as using a terminal block. The first thing we'll start out with is creating a UART connection between the MP3 Player Shield and the Arduino Mega board. There aren't many pins available on this shield, so what we're going to do is go ahead and just connect a motion sensor to it, and then connect the RX-TX pins to the RX-TX pins of the Arduino Mega board. We'll connect the data pin of the motion sensor to pin 5 and the power pins to the 5-volt pin and the ground pin. For the UART connection, as you can see, the RX pin of the SparkFun board goes to the TX pin of the Arduino, and the TX pin of the SparkFun board goes to the RX pin of the Arduino. The serial monitor on the Arduino Mega board operates using the RX and TX pins of the default serial port on pins 0 and 1. To avoid interfering with uploading and debugging code, I'm going to just use the RX1, TX1 pins on the Arduino board. Now you may want to run a couple devices from your Arduino Mega board. I'm just going to use 2 servo motors as an example. I'm going to connect the signal pins of the servo motors to pins 8 and 9 on my Arduino board, and since I can keep the current under 1 amp, I'm going to go ahead and provide power on the rails of my breadboard. First we'll look at the code for the SparkFun board with the MP3 Player Shield. As you can see in the setup, we initialize UART communication at 115200 baud for real-time debugging and sending operational signals. We also configure the PIR sensor input and initialize the SD card and the MP3 player for audio playback. If you look down here in the loop, we set up the code to monitor the PIR sensor, changing state based on presence or absence of motion. And for the UART control signals, we see it outputs start over UART when motion is first detected, and that signals the servo motors to move on the other board, and then it'll output stop over UART when the motion is no longer detected, and that'll tell the servo motors to stop. Now let's take a quick look at the code for the Arduino Mega board. In the setup, you can see the UART communication utilizes 2 serial interfaces. One is serial.begin, and they're both at 115200 baud. This first one's for debugging messages, and the serial 1.begin, that one's for receiving commands from the SparkFun board. And then we have servo initialization, which we attach servos to pins 8 and 10, preparing them for movement upon receiving commands from the SparkFun board. So if we look at the loop, we see that we receive commands. It listens on serial 1 for start or stop commands, and that indicates the beginning or end of the MP3 playback and any movement from our servos. And our command actions are start, which initiates continuous servo sweep, and stop, which resets the servos to their initial position. And the rest of the code implements a back and forth sweeping motion for both servos, and that's calculated to last for the duration of the music playback. The dual UART that we see in this code really highlights the use of separate serial ports for debugging and inter-Arduino communication, and that's a critical feature for coordinated control when you're using multiple Arduinos. Once the motion sensor on the SparkFun board detects motion, it plays tracks for 30 seconds with 2-second delays between each track, and during that 30 seconds, these two servos alternate sweeping motions. Well, what if I wanted to extend my project to add another board and another device or something else? I can do that, and in this example I'm going to add another board to operate a set of 10 LEDs. I'm going to go ahead and provide power for my LEDs on the top rail here of my breadboard, and in the bottom rail I'm going to provide power for my servos like I did in the previous example. And I'm going to link my two Arduino megaboards using UART communication, but instead of using RX1 TX1, I'm going to use RX2 TX2 as you can see here in this diagram. When integrating a third Arduino board dedicated to LED control into the system, the original SparkFun sketch, it doesn't change, and that's because the function of motion detection, MP3 track selection and playback, and UART signaling is unchanged. The addition of the third board for LED control primarily impacts how the second board, the one with the servo control, interacts with the system. We're extending the UART command chain, enabling a sequence of actions, the music playback, the servo movement, and now the LED pattern activation, all to be triggered by a single event, which illustrates a layered approach to interactive project design where motion detection initiates a cascade of reactions across multiple boards, each adding a different dimension to the interactive experience. Well, let's see this 3-board setup in action once I activate the motion sensor here. And this will continue for 30 seconds and then stop. There are several other methods available for connecting multiple Arduino boards. Each has its own advantage in use, but just to name a few, there's I2C or I2C connection, there's SPI connection, wireless communication such as Wi-Fi, Bluetooth, RF modules. We're going to go ahead and take a look at I2C connection. Now for this quick demo, we're going to go back to our original setup of a motion sensor on a SparkFun board and 2 servos on an Arduino Mega board. Except our connection won't be UART, but it'll be I2C connection, which uses the SCL and SCA pins, as you can see in the diagram. Without making this video really long, I just want to briefly comment on the code. The I2C communication between these two sketches shows a clear master-slave relationship, and that's essential for synchronized activities in multi-device projects. In our setup, the SparkFun board with the motion sensor is set up as the master board, and the Arduino Mega board with the servos is set up as the slave board. The master board detects motion and controls MP3 playback while coordinating with the slave board to manage the servo movements. And in this setup, we're effectively using I2C's capabilities for direct two-way communication, and this allows for real-time control and synchronization between different components that we have in our system. Here's our setup with the I2C connection. Visually, it should look the exact as it did with the UART connection. We're just using a different communication protocol, the I2C. That's it. Well, I hope this video was helpful to you, especially if you're new or newer. Hopefully you're encouraged to go out and learn about communication protocols and expand your Arduino projects. If you did find this helpful, don't forget to like the video by clicking the thumbs up and share it with somebody else who might find it useful, and consider subscribing, and I'll see you again next time.